As we look at 2.3b, then we begin to get into linear equations that are a little bit more complicated. So I want to take a look at a list of what particular order are we supposed to do problems in. So the first thing we should do is if our equation has fractions, we should clear fractions. And we'll demonstrate that as we go through some. If our equation has parentheses, we need to clear parentheses. Then we want to simplify each side. So if there are like terms and so forth, if there are any operations that we can apply on each individual side, we want to simplify them. And then we want to get our variables on one side and our numbers on the other side. It doesn't really matter which side we get which on, but we want the variable we're trying to isolate on one side. If it doesn't have that variable, we want it on the other side. And these are terms that we are moving back and forth. And the way we move terms back and forth is by adding and subtracting. After we get our variables on one side and a number on the other side, we want to isolate the variable, or we could say remove any coefficient. And that's going to be done by either multiplying or dividing. So for example, if we have 4x on one side, 16 on the other, to get rid of the coefficient, the opposite of multiplying, we would divide on both sides. Then the last thing we should do is we should check. Now, we don't always check our work, don't always check to make sure our solution is the correct solution, but that is a good practice to be in. So if we look at this example, this problem doesn't have fractions, so there are no fractions for us to clear. But it does have parentheses. So we want to clear the parentheses, so we're going to distribute. So that'll give us negative 4 times x. Negative times negative, which will make a positive 28, minus 30 equals negative 2. We cleared parentheses. Now we want to simplify each side. There's nothing to simplify on the right side right now, but on the left side we have like terms. Those are both just numbers. So positive 28 minus 30, these have opposite signs, so we subtract the numbers. 30 minus 28, which is 2. Take the sign of the larger number. So that's as far as we can simplify the left side. So now that we have simplified each side, we want to get our variables on one side, our numbers on the other. So the only variable term we have is this one. So we might as well leave it where it is, get all of our number terms to the other side. So how do we get rid of a minus 2? Well, we're either going to add or subtract. So the opposite of a subtracting 2 is to add 2. And when we're moving things off of one side to the other side, we have to do that on both sides. We're adding 2 here, so we do the same thing over here. So minus 2 plus 2 cancel. That leaves us negative 4x. On the other side, negative 2 plus 2 cancel. And we can't just leave this side blank, so we need to put a 0 saying that we have nothing left on that side. So negative 4x equals 0. So we've got our variables on one side, numbers on the other, so then step 5 is to isolate our variable. That negative 4 is times x, so the opposite of multiplying is to divide. So divide both sides by that negative 4, so that negative 4 over negative 4 cancels. 0 divided by anything is 0. Remember, anything divided by itself makes 1. Whether it's 2 over 2, 5 over 5, 7 over 7, whatever divided by itself makes 1. So 1x or x equals 0. And then, of course, it would be a good idea to go back and check. All right, for the next one, step 1, clear fractions. So this one has fractions. So we want to multiply the left side and the right side by something that will make the 5s on bottom go away. So if we think about, if we have a 5 on bottom, the opposite of dividing by 5 is to multiply by 5. If I had a 2 on bottom, I would get rid of a 2 on bottom by multiplying by 2. In this case, it's a 5 that we have on bottom. So we're going to multiply by 5, and we can't just pick one term or the other to multiply. We have to multiply every term on the left by something and every term on the right by the same thing. So we're going to do 5 times, and then we're going to do 5 times the next term. And on the right side, we're going to do 5 times negative 9/5. Now, I often like to put these 5s over 1 just as a reminder that that 5 is on top. So that when I look at this multiplication here, I can see if we're multiplying and we have the same number on top and bottom, we can reduce them. And that 5 cancels. That leaves us a 2 on top. 2 divided by 1 is 2, and then bring down our x. Here, 5 and 5 reduce. 5 goes into 5 once. 5 goes into 5 once. So we're left with 1 on top. 1 times 1 is 1. 1 times 1 on bottom is 1. So 1 over 1, or we could just call that 1. So again, let me say that. If we multiply the top together, we get 1. If we multiply the bottom together, we get 1. Well, anything over itself is 1. On the other side, we have a positive times a negative, so we're going to get a negative. The 5's reduced. 5 goes into 5 once. 5 goes into 5 once. So we're left with 1 times 9 over 1 times 1. Well, anything divided by 1 is itself. Plus 1 equals negative 9. That's what we get when we multiply everything by 5. So we've made the fractions go away. Step 2 is to clear parentheses. Well, we have no parentheses. Step 3 is to simplify each side. Well, there's nothing to simplify on either side because these can't be combined, and there's only one term here. So now we want to get all of the x's on one side. So this is the only x term, so have it on one side. Every term that doesn't have an x to the other side. So we want to move this. So to make it go away from this side, we do the opposite. So subtract 1. So bring down the 2x. 1 minus 1 is 0. So we could put the 0 or we could leave it off. These have the same signs, so add the digits, take the sign of the bigger. So we get 2x equals negative 10. Then the next step says to isolate the x, so make the coefficient go away. So the opposite of multiplying is to divide, so divide both sides by 2. So 2 over 2 is 1, so we get 1x equals negative over positive 10 divided by 2, or x equals negative 5. So on this one, by making the fractions go away and getting an equation that had no fractions, it turned it into a much easier equation to solve. Here we have a fraction, so we want to get rid of the fractions. So we have one fraction. This whole thing is one term. There's nothing added to or subtracted from this term. Now the numerator does have some adding, but there's nothing that's added to this. So the opposite of dividing by 4 would be to multiply by 4. So we're going to multiply this term by 4 and both terms on the other side by 4. Now, again, I like to put that 4 over 1. Remind myself this is 4 is on top. So the 4 over 4 makes 1. So on the left side, we're left with 1 times 2 times the parentheses. So the 4 on the right side, let's put the 4 first, and that's times 5x minus 2. So we, excuse me, we made the parentheses go away by multiplying both sides by the same thing. I'm sorry, we made the fractions go away, not the parentheses. Now we want to make the parentheses go away. So distribute on this side, distribute on this side. So we have 2 times x, 2 times 5. On the other side, we have 4 times 5x, and then 4 times 2. So 2 times x is 2x. 2 times 5 is 10. That's supposed to be an x. 4 times 5x is 20x. 4 times 2 is 8. Some people get confused here on why is the negative here, not here. It doesn't really matter. Just keep in mind that we're doing a positive times a negative, so it's going to be negative. And 4 times 2 is 8. Now, neither side can be simplified. These don't combine. These don't combine. So we want to get our x's on one side. If it doesn't have an x, get it to the other side. So let's get our x's on the left. So we want all of our x's over here, so we want to make this x go away over here. That's a plus 20x. To make it go away, we want to subtract it. Subtract it. So on the right side, 20 minus 20 is 0, so those cancel. And that leaves us just the minus 8 term. On the other side, we have these two are alike. Opposite sign. So we're going to do 20 minus 2, which is 18. X. Take the larger sign. Bring down the 10. So our x's are all on the left. Now to get things that don't have an x to the other side, this doesn't have an x, so we want it on the other side. So the opposite of adding 10 is to subtract 10. So 10 minus 10 is 0. Negative 8 minus 10, those have the same signs. So we add those numbers, take the sign of the bigger. And then to get x by itself, we just undo this. That's multiplied, so to undo it, we divide. Divide. Anything over itself makes 1, so we get 1x equals anything over itself makes 1. Or we could just call that, instead of 1 times x, we can just call that x equals 1. On this next one, no fraction. So get rid of the parentheses. So we get 15x minus 3 equals 15x minus 3. Notice those two sides are exact matches. If we were to rearrange this, if we were to try to get all of our 15x minus 15x would make 0 there, leaving us a minus 3. 15x minus 15x would make a 0 there. And notice that's a true statement. No matter what x is, those sides are always going to be the same. Same thing at this point. Since they say the same, no matter what number we put in for x, this side and this side will be the same. So when that happens, and often the way it'll appear is when we try to get rid of our x's on one side, they actually all go away. If we end up with a number equal in itself, that's a true statement, and the solution will be all real numbers. Any number that you plug in is going to work, is going to be a solution here. On the other hand, if we were to plug in a number or get rid of our x's and get one number on one side, a different number on the other side, well, that's never true. If that happens, then that means for this equation, there's no solution. So let's take a look at another one. So if we distribute on the right side, we don't have any fractions to clear, so we want to clear parentheses. So 4 times x is 4x. 4 times 5 is 20. Notice these are never going to be true at the same time. 4x plus 1 and 4x plus 20 can't possibly be the same. If we try to get all of the x's on the same side, move this 4x to the other side, so the opposite of adding would be to take it away. So 4x minus 4x cancels, leaving 20. Well, on the other side, 4x minus 4x cancels, leaving 1. 1 and 20 are not the same number. So as we mentioned on the previous problem, if we try to isolate our variables and the variables go away and we end up with a false statement, then that means for this problem there is no solution. All right, so let's take a look at this one. So let's look at clearing the fractions. Let's look at clearing the fractions. So we have a denominator of 4 and a denominator of 10. We could reduce our fractions first, but since that doesn't always work, let's not reduce. But we want to multiply both sides by something that will make the 4 go away and the 10 go away. So if you think about if you have a 4 on bottom, if we multiply both sides by 4, the 4's would go away. If we have a 10 on bottom, if we multiply both sides by 10, the 10's would go away. Well, if we multiply both sides by 4 and both sides by 10, we've really multiplied both sides by 40. So we could multiply the left side times 40 and the right side times 40. Now, it turns out there's also a smaller number that we could use to multiply everything by. It's a number that 4 would go into and that 10 would also go into, and that number is 20. 4 goes into 20, 10 goes into 20, so we could use that as well, but we'll just use 40. So if we do 40 times the left side, notice we have a 4 on bottom, a 40 on top. So 4 goes into 4 once, 4 goes into 40 10 times. That leaves us with 10 times 2, or 20, times x minus 2. On the other side, we're going to do 40 times 2 times x plus 1 over 10, so we keep the fraction just like it is. And if we're multiplying by 40, 10 goes into 10 once, 10 goes into 40 4 times, so we're left with 4 times 2 times the parentheses. So by multiplying by 40, 40 reduced this denominator, 40 reduced that denominator, and so now we don't have any denominators. So now we want to clear our fractions. So distribute the 20. 20 times x is 20x. When we do 20 times negative 2, a positive times a negative is negative. 20 times 2 is 40. And then we distribute on the other side. 8 times x is 8x. 8 times 1 is 8. So we've gotten rid of fractions. We've gotten rid of parentheses. There's nothing to simplify on this side, nothing to simplify on this side. So now we want to get all of our variables on the same side. So let's get our x's on the left side. So that means we want to get rid of the x's on the right. So to make this 8x go away, we're going to take 8x away from both sides. 8 minus 8 gives us no x's, 0 x's. So we're left with just an 8. Remember, 0 x's, or that's just nothing. And then bring down the 8. 20 minus 8 is 12, so 12 x's. Bring down the 40. So all of our x terms are on the left. And anything that doesn't have an x, we want to move over. So if we have a minus 40, to make it go away, the opposite would be to add 40. So negative 40 plus 40 is 0, so those cancel. So we get 12x equals 8 plus 40, or 48. And then to get x by itself, divide both sides by 12. Because 12 over 12 makes 1. So 1x, or x. 48 divided by 12 is 4. So we're able to get x by itself. Let's do this one. And this is a 2. So we're wanting to solve for y. We want to begin by getting rid of our fractions. So we want to multiply everything on the left by something and everything on the right by the same number. So you have to think about what can we multiply both sides by. That will make a 2 go away, and that'll also make a 6 go away. We could multiply by 12. You could say 2 times 6 is 12, so we're going to multiply by 12. That would work because if we multiply that term, 2 goes into 12, so that 2 is gone. And if we multiply this term, 6 goes into 12, so the 6 is gone. But let's do a smaller number. That would work, but let's think of a smaller number. If we were getting common denominators for these two fractions, our common denominator would be 6. Remember, a common denominator is a multiple of this and a multiple of that. Multiples of 2 are 2, 4, 6, 8, 10. Multiples of 6 are 6, 12, 18, 24. So the smallest number that is a multiple of 2 and a multiple of 6 is 6. So we can multiply both sides by 6, and that's going to make our denominator go away. Think about it. 2 goes into 6, also goes into 6. So since we have two terms on the left side, we have to do 6 of those. So 6 times 7 over 2y, and 6 times 9 over 6. And on the other side, we have two terms, so we have to do 6 times each of those. So 6 times 3y, and 6 times 7. So when we do 6 times the first one, 2 goes into 2 once. So that leaves us with 3 times 1. Just a 1 on bottom. 1 times 1 times y. For the next term, 6 goes into 6 once. 6 goes into 6 once, so we're left with 1 times 9 over 1. On the other side, 6 times 3 is 18y. 6 times 7 is 42. So we have made the fractions go away. There are no parentheses, so we want our y on one side. So let's make these y's go away on this side. So if they're positive here, we want to take them away on both sides. So 21 minus 18 is 3. Bring down the 9. 18 minus 18 is 0, so no y's, or we could just say 0. Bring down the minus 42. 3y plus 9 equals negative 42. We have our y's on this side, so let's get our numbers to the other side. So if we have a plus 9, the opposite would be to subtract 9. So bring down the 3y. 9 minus 9 makes 0. And then when we put these together, they're both negative. So when our signs are the same, we add the digits. So 1, carry your 1. Take the sign of the bigger. And now to get y by itself, the opposite of multiplying is to divide. That should be 51 here, not 5y. So the 3's cancel. 3 over 3 is 1, y. And then a negative divided by a positive is negative. And then do 51 divided by 3. So 3 goes into 5 once. 1 times 3. 5 minus 3 is 2. Bring down your 1. 3 goes into 21 7 times. So 17.